We are asked to find the equation of the line that contains these 2 points, 2 comma 6 and 8 comma 10. So when we look at the choices in this multiple choice problem, we notice that each of them have a different slope. Therefore, all we have to do is get the correct slope and it will lead us directly to the answer. So recall, when you're given 2 points, you could find the slope using this formula, y2 minus y1 over x2 minus x1, which is simply the change in y over the change in x, otherwise known as the rise over the run. So let's look at the numerator first. Here's our y2 value, there's our y1 value. So here in blue, in the numerator, we're going to have 10 minus 6. In the denominator, we're going to do this x value minus that x value, 8 minus 2, and that's going to give us 4 over 6. If we break down this fraction, we're going to have 2 times 2 in the numerator, 2 times 3 in the denominator. 2 over 2 is 1, therefore our slope is 2 over 3. Sorry, that's a little bit off the page. Therefore, immediately we know that the correct choice is A. Okay, so we already know the choice is A, but folks, I want to show you how to do this using Desmos, just in case for whatever reason you didn't remember the formula for the slope. So when you have points like this, you can create a table. So I'll go to the plus sign, create a table, and let's enter these 2 points, 2, tab 6, tab 8, tab 10. Okay, next I'm going to go to this little icon right here and hit add regression. And because it's set as a linear regression by default, it immediately gives us our equation. So you could see here it's y equals 0.6667x plus 4.667. So the answers that are given are in fraction form. So there's 2 ways to pick choice A here. One is to recognize that 0.6667 is 2/3. The other way to recognize it is, look, this y-intercept that it gives you the equation of is 4.667. It is not an integer. So the only y-intercept in any of the choices that is not an integer is choice A. Okay, folks, let's say you create this table, you see the linear regression, and you look at this equation. By the way, see these statistics, r squared equals 1. That means it's very sure that that's the correct equation. But suppose you look at 0.6667x and you're not sure which of these fractions it is. You know it's going to be 2/3 or 3/2, but you're not quite sure. So what you're going to use is the decimal to fraction conversion feature that Desmos offers. So you go ahead and you start entering 6667 here, and you hit the fraction button, and look, it gives you this fraction, which is not helpful. You want the reduced version. So look at this. If you enter more 6s, okay, watch what happens. Look, first the fraction icon goes away, so you're thinking you're doing something wrong. But look at this. If you keep entering more 6s, eventually the icon returns and it gives you what you want. Unbelievable. So when you're entering decimals and you want to convert to a fraction and use that icon, sometimes you have to enter as many as 16 digits to get it in the format you want. Now, if you look at the other fraction the other decimal that's given to you in this linear regression, let's look at this. 4.6667. And we hit the fraction button. That is not helpful. We're trying to find out, is that 14 over 3? This is not helpful. So look at this. If you start adding in more of these 6s, all right, look, the fraction sign disappears. Then you add more. Keep going. Fraction sign reappears, and boom, 14 over 3, which is the version of the fraction we want. Desmos is so picky, folks. That's why I don't like to completely rely on it in terms of the SAT. It's such a powerful weapon, but it's filled with little quirks like this. And whenever I find one, I'm going to try to make a little video to demonstrate this.